Hi, I'm Arnav Jaiswal from Titan School Amravati, and this is my board build for the IIT Madras Electronics course. The board is made up of an aluminium chassis and holds a Raspberry Pi Pico as the main microcontroller of the build. It has 4 mecanum wheels on BO motors of 100 RPM. These are connected to two L298N motor driver modules powered by these two lithium ion cells in series. The bot is controlled by this transmitter I built, which uses a ESP32 module connected to a joystick and two buttons for input, and a TFT screen for a dashboard of the bot. Before I continue further, though, I have to address a problem that I faced that forced me to change the plan of my project slightly. Originally, I was going to use these NRF modules to communicate between my transmitter and the Pico. But after several failed attempts, I couldn't get the Pico to interface with it. I even designed my PCB around this module. Writing anything to the NRF over SPI would just fail, and reading from it always returned an 8 no matter what. So I was forced to abandon this approach. So here's what I came up with as an alternative. On the back of the board, I have attached the ESP8266 module through a buck converter. The ESP8266 talks to the transmitter over ESP now protocol, which is built in these cores, and then the Node MCU sends that over to the Pico over serial using the software serial library. With that out of the way, I would like to talk about how I designed the bot. From the start, I knew I wanted to mimic the basic design of a Mars rover. I was very inspired by a few projects I saw online, and I sketched out a basic brainstorm of how the project could work. Another thing I decided pretty early on was that I was going to build the chassis from this aluminum sheet that I had available at my home. It is easy to cut, and after folding it, it becomes surprisingly strong. Next up was designing the circuit. To design the actual circuit, I used KiCad schematic editor to lay out the circuit of the project. I needed to make sure that I had enough pins and where I would assign them to. After that was done, I used a perf board and hand soldered all the parts onto the board. I soldered female pin headers for the Pico and this 4-channel voltage changer. I had to use this because my ultrasonic sensor module only reliably works on 5 volts. On the back, you can see my patchy soldering skills, but the important thing is it works. Now, let's get on to how the code for this project works. I'll start off with the transmitter. I use the TFT ESPI library for the TFT display, and I designed this dashboard interface to look vaguely like my desktop Hyperland system on AS Linux, even having the same gruff box color scheme. As for the wireless transmission, I approximate the direction of the joystick in one of 8 directions, depending on whichever vector is closest to the current position that you can see here. I then set that along with the current state of both the buttons. A problem I faced was that the Node MCU on the board sends random signals on its pins on startup, so I needed to make sure that those won't get confused as valid controls. So I start the packet off and end the packet with a verifying byte AA so that the Pico can check if it received the right packet or not. For the Node MCU code, it just receives the packet over ESP now and sends it on the Pico over software serial as is. So basically, it is just acting as an antenna here. On the Pico, I have to manage 4 things for which I made separate header files. Stepper.h, which handles all of the head movement along with the ultrasonic sensor and the OLED. Then movement.h, which handles all of the wheel directions of the bot and what to send over to the L298N. After that, I made kicker servo.h, which handles all of the kicking using the servo at the front. And of course, the main sketch. For the eyes, I used a library I found online that draws animated eyes for this exact screen, which was very helpful. For the servo, I used servo.h, and for the serial communication, I used software serial. After making all of this work together, which took a lot of hours of debugging and headaches, I finally had something that worked.